A diabetes epidemic is taking over the world, and on a cellular level, beta cell impairment is one of the key components of type 2 diabetes. Pancreatic beta cells are normally supposed to secrete more insulin when blood sugar levels rise. Insulin then lowers the blood sugar by signaling to other cells to take in more glucose from the blood, slowing the breakdown of glycogen into glucose in the liver, and by blocking other cells from converting fats and amino acids into sugars.
Beta cells have glucose receptors embedded in their membrane. When glucose in the blood passes by the beta cell, if it matches into the shape of a receptor, it will be allowed into the cell. The amount of glucose that enters the cell determines the amount of insulin that gets produced. Once glucose enters the beta cell, it is broken down in a process called cellular respiration, which is used to create energy. This energy is used to close the cell's potassium channels. To make up for the lack of potassium ions entering the cell opens its calcium ion channels to still allow positively charged ions to go through.
The calcium ions then trigger the endoplasmic reticulum, or the manufacturing center of the cell, to produce more insulin, and they stimulate the beta cell to release the insulin that it has stored.
As you can see, the pathway leading to insulin production is similar to falling dominoes. Rather than only being one simple step, it involves many different stages that create a chain reaction with each other. This also means, though, that there are many different pieces that can fall out of place and disrupt the entire process.
A common reason of beta cell impairment is sustained periods of hyperglycemia, or high blood sugar.
This can cause the proteins of the endoplasmic reticulum to unfold. As the unfolded proteins accumulate, the endoplasmic reticulum loses its function and can no longer produce insulin. Although cells have ways of combating endoplasmic reticulum stress, such as by trying to fix the endoplasmic reticulum and using backup methods to create insulin, if the amount of unfolded proteins continues to grow, the cell will eventually deem the endoplasmic reticulum as beyond repair, and will induce apoptosis, or the cell self-destruct mechanism.
Misshapen amylin can also lead to decreased insulin production.
Amylin is a protein whose purpose is to slow down the digestive system to cause people to feel full after eating. Amylin is secreted from beta cells in the same vesicles as insulin.
So when there's a high demand for insulin, amylin gets produced just as quickly. However, the rapid production of amylin often causes it to be poorly formed. Instead of leaving the cell, these deformed amylin molecules stack on top of each other and prohibit the cell from producing insulin. While sometimes beta cell function can be repaired, often the destruction is permanent, especially when it involves damaged cellular equipment or apoptosis. Luckily, only a small amount of insulin is usually enough to take care of our blood sugar levels, and we can live with a few damaged beta cells. However, this also means that by the time a person is diagnosed with diabetes, 70 to 90% of their beta cells are already damaged or dead. One area of active research is getting beta cells to regenerate or function better. If either of these could be accomplished, then type 2 diabetes could be cured.